Tatiana Hovorushenko, General Chair of the fourth International Workshop on Intelligent Information Technologies and Information Security Systems, IntelliSys 2023. Thank you all for participating in our workshop, for your interesting papers. I am glad to welcome all of you to our workshop, but unfortunately online again, not within the walls of our Khmelnytskyi National University. Fourth International Workshop in IntelliSys 2023 is organized by Computer Engineering and Information Systems Department of Khmelnytskyi National University with the support, informational support of the public organization Ukrainian Scientific and Educational IT Society. The IntelliSys 2023 focuses on all the technical and practical aspects of the latest research and results of international scientists and practitioners related to intelligent information technologies, information security systems, computer and cyber physical systems and networks. This workshop provides opportunities to exchange new ideas, to establish business or research relations, and to find global partners for future collaboration. I hope that the workshop results make a significant contribution to the development of intelligent information technologies, information security systems, computer and cyber physical systems and networks in Ukraine and in the world. The program of our workshop includes a plenary session today from 2 till 5:45 p.m. 3 sections. Section first, Intelligent Information Technologies. Section second, Systems of Information Security. And the section third, Computer Systems and Networks, which will take place tomorrow and the day after tomorrow according to our program. As well as awards and close ceremony, which will take place on Friday, March 24, from 3:45 to 4 p.m. And I invite everyone to attend all the events of our workshop. I wish everyone fruitful work and interesting presentations. Welcome. And the next speaker who will say greetings words is Professor Oleg Senyuk, Vice-Rector of Scientific Work of Khmelnytskyi National University. Welcome, Oleg Mykolaievich.
Dear conference participants, dear organizers, it is a great joy to greet you all. I am very pleased to speak to today's conferences. This conference is the first conference at the university this year and the fourth international workshop. Unfortunately, there are reasons that do not allow us to meet in person. At first it was the coronavirus, and now it is the war. Ukraine is now going through times beyond difficult, and in these conditions, the scientists and engage in our work, and we also help internally displaced persons and the armed forces of Ukraine. From the first day of the war, support center for internally displaced persons and armed forces of Ukraine was established at Khmelnytskyi National University, and work was carried out to counter cyber attacks. I am convinced that we Ukrainians are a strong nation and will definitely win. The university conducts fundamental and applied research to resolve issues of reconstruction of Ukraine in the war and post-war periods. Our university has powerful research and production laboratories, as well as research center of various profiles. The university performs basic and applied research and many priority areas of science and technology. Today, the priority direction of science development of our university is to increase the volume of service and developments under business agreements and international grants. There are still enough scientists in Ukraine and in particular at our university who have significant knowledge and skills, practical experience, and can critically think and evaluate any process. The main task of Ukraine universities today is to use scientific potential for the reconstruction of Ukraine. I wish all the participants to see many interesting presentations of participate in constructive discussions and to discover something new. Thank you.
Great, thanks. Next welcome speech will say by International Program Committee Chair, Professor Sergei Lysenko, Khmelnytsky National University, Ukraine. Welcome, Sergei.
Thank you. Do you hear me?
Yes.
Okay. So, dear colleagues, dear distinguished guests, ladies, journalists, Pani, Panova, it's given me great pleasure to extend a warm welcome to all of you to our workshop. Today we are gathered to share our knowledges, exchange ideas, and explore the latest advancement of our prospective fields of information technologies. I believe that our workshop provides us with a unique opportunity to learn from each other, collaborate, and make a significant contribution toward the advancement of science and technology. As we are all aware, Ukraine is a country under Russian aggression, but we are strong as no time. As we will discuss and deliberate on various topics, I encourage all of you to make the most of this opportunity to interact with each other, share your experience, and learn from each other. Let's make this workshop a platform for intellectual exchange and cooperation. I'd like to take opportunity to thank all the participants, speakers, sponsors, organizers, reviewers for their contribution toward making this workshop a reality. Our presence and participation are greatly appreciated, and we look forward to the engaging and productive conference. So once again, welcome to our workshop in Telesis, and I hope that you stay here with both enjoyable, enriching, and safe. Thank you.
Thank you. Next speaker who will say greetings words is organizing committee co-chair, Dr. Elizaveta Khnachuk, Khmelnytsky National University, Ukraine. Welcome, Elizaveta.
Dear conference participants, we are pleased to welcome you to the International Workshop Intelisys 2023. This event gathers IT specialists from different countries of the world every year. It is a great opportunity for specialists and scientists from different countries to exchange experience, new developments, achievements, and discoveries. Despite the war in Ukraine, we continue to work for the victory and revival of Ukraine. The organizing committee made every effort to ensure that this workshop was held at a high level. We wish everyone effective work, interesting reports, and discussions. We hope that you are all safe and that our workshop will be interesting and useful for all participants. Slava Ukraini!
Героям слава! Great, thanks. Now we will have the following presentation about Intelisys 2023 trends. I am a speaker. Now I will share my presentation. And fourth international workshop on intelligent information technologies and systems of information security, Intelisys 2023, is organized by Computer Engineering and Information Systems Department of Khmelnytsky National University with the information support of the public organization, Ukrainian Scientific and Educational IT Society. The IntelliSys 2023 was originally planned to have a physical location, Melnitsky, Kamenetska Street 112, building number 1 of Melnitsky National University, but Russia's war against Ukraine, which began on February 24, 2022, thwarted all plans. So unfortunately, now this event is conducted remotely again in video conferencing format using the Zoom platform. For the fourth year in a row, we have a situation where we can't meet live, but have to use only online communication. I believe that Ukraine will win, and next year, next workshop, we will definitely meet live in Khmelnytsky, a picturesque city on the book at our native Khmelnytsky National University. I offer a moment of silence to honor the memory of all the dead civilian and military Ukrainians. Thank you. Now we would like to thank the armed forces of Ukraine for providing security to perform this work. This work and our workshop has become possible only because of the resilience and courage of the Ukrainian army. General chairs of the fourth international workshop in the IntelliSys 2023 are me, Professor Tatiana Gorushenko, and my colleague, Professor Oleg Savenko. Chairs of the International Program Committee are Professor Sergei Lysenko, Khmelnytsky National University, and Dr. Peter Popov, City University of London, United Kingdom. Organizing committee chairs are Professor Alexander Barmak and Dr. Elizaveta Fachuk, Khmelnytsky National University, Ukraine. International Program Committee has 28 members. 100% of the IntelliSys 2023 International Program Committee members have more than 15 DBLP papers. There are the representatives of 6 Ukrainian universities and 12 universities from around the world: United Kingdom, USA, Austria, Slovakia, Czech Republic, Egypt, Poland, and Estonia. Fourth international workshop, IntelliSys 2023, received 131 submissions from Ukraine and the world. All papers were evaluated by 2 or 3 reviewers. Based on the reviews, a rating of papers was compiled. Papers with a positive average scores were accepted for presentation at the workshop. According to the decision of the International Program Committee, 55 papers were accepted for presentation at the workshop. The IntelliSys 2023 joint scientists from Ukraine, United Kingdom, USA, Slovakia, Czech Republic, Austria, Poland, Estonia, Germany, Egypt, Algeria, Kazakhstan, Kyrgyzstan, Israel, Canada, Malta, Switzerland, etc. In general, the representatives from 27 universities from around the world, and 4 industrial partners from Israel, Canada, Malta, and Switzerland. On this slide, you can see list of universities and industrial partners from around the world, the representatives of which will take part in our fourth workshop. On this slide, you can see lists of Ukrainian university and industrial partners, the representatives of which will take part in our fourth workshop. There are 4 industrial partners from Ukraine and 36 Ukrainian universities. Summary, we have 71 institutions will take part in our fourth workshop. So final acceptance rate is 42% in this year. And I wish everyone fruitful work and interesting presentations. Welcome. And now we will have a plenary session. Our first plenary presentation is towards intelligent technology for error detection and quality evaluation of business process models by Andriy Kop and Dmytro Orlovsky, National Technical University, Kharkiv Polytechnic Institute, Ukraine. Who is speaking? Andriy, yes?
Yeah, good day. I'm a speaker. May I share the slides, right? Okay. So I hope you can see the slides and hear me properly. So I guess I can start. I would like to thank you for this invitation to deliver the keynote presentation about our paper towards intelligent technology for error detection and quality evaluation of business process models. It's prepared by me and my colleague Dmytro Orlovsky. We're employees of Department of Software Engineering and Management Intelligent Technologies of National Technical University, Kharkiv Polytechnic Institute. And let's begin with the context of contents of this presentation. So our study is organized in several parts. The first part describes motivation, what is business process modeling and why do we need such a technique. And we briefly describe the state of the art in the field, as well as give the problem statement for the quality analysis of business process models. Then I'm going to present materials and methods we propose in this study. It will be intelligent technology for error detection and quality evaluation of business process models. And then I will present the obtained experimental results we got using the proposed approach and discuss this result. And finally, the conclusion will be made and future work in this field will be proposed and summarized. Let's begin with the motivation. So what is business process management, or simply BPM? Is a methodology or managerial technique which aligns information technology and business stakeholders in the organization. And as a business process, we can understood a structured collection of activities driven by events and decision-making points that affect such activities. As for business process models, usually they are given as graphical diagrams similar to workflow charts. So the organizational activities depicted using these diagrams must be of high quality to ensure that these models will be understandable and maintainable for all the parties involved in BPM projects. because poorly designed business process models are not only useless for the analysis or improvement of enterprise process, but they can even lead to new mistakes or inefficiencies when they are used to plan new or improved business process or capture software requirements for IT systems and other cases. And moreover, poorly designed business process models may also reflect inefficiencies in real process. So this is why the quality of created process models should be carefully controlled for early detection and prevention of errors at the design stage before they became real errors in some organizational workflows or supporting enterprise IT systems. Because they may cause some unpredicted expenses, time losses, or even some dangerous impact on humanity or the environment if we deal with critical industries. So what is BPMN? I mentioned before, it stands for the Business Process Model and Notation, and nowadays is a standard for process modeling in the most industries. According to the latest available surveys in this field, only 4% of respondents use some third-party notations, 18% use a little bit obsolete event-driven process chains, but more than 64% organizations that tend to practice BPM approach use this notation, BPMN, to describe their organizational activities. And BPMN models could be seen as workflow descriptions that depict sequences of tasks and events using control flows. As you may see in this slide, there are several primitives or symbols used in the BPMN notation. There are start events which demonstrate where process begins. There are tasks and sub-process that can expand another process that show work units. There are also intermediate events that demonstrate some things that happen in an instance within a process, and gateways of different logic types, such as XOR logic, OR logic, and AND or parallel logic gateways that implement process branching and merging. And finally, there are also end events that show where a process finishes. These are main constructive elements of BPMN models, but there are more. There are data objects which can demonstrate information flows, pools that describe business process boundaries, and lanes that describe participants of different process tasks. What are existing approaches that are devoted to business process model quality analysis and evaluation? First of all, numerous of frameworks exist, such as the guidelines of modeling, semiotic quality framework, and maybe the most influential in this field is the process modeling guidelines framework. Also, we must take into account the definition by ISO standards of 9001 family of standards, which declares quality as a degree to which a set of inherent characteristics fulfills requirements. So we propose similarly understandable and quantitatively measurable definition of process model quality, which says it's a degree to which a model fulfills requirements of modeling rules. And also we considered in this study existing studies in different approaches in quality evaluation of business process models using metrics and thresholds. There are different metrics such as size-based, like the number of different elements, structuredness metrics, like each branching gateway must be followed by respective joining gateway, or connectivity metrics like the density values, and control flow complexity analysis metrics that represent possible combinations of process states after the split gateways. And all of these metrics allow to evaluate and improve maintainability as one of the business process model quality attributes, but all of them separately focus on different aspects, different things in the process structure they measure. So we have proposed one more solution, and in general, to maybe motivate again this research, we can say that poorly designed models are sources of implementation errors and costs that can be caused by these errors, or even some harmful impact, as if we talk about process models of critical industries. And the main problem are not some incomplete metrics, but the general business process management life cycle, which consists of process design, implementation, monitoring, and control, but it lacks of continuous control for the created BPMN models for their quality. And therefore, in this study, we proposed the extension of BPM process with the quality analysis of designed BPMN models. So, of course, the manual quality analysis to detect and eliminate errors could be a challenging problem. And this is why, just like software engineers who have compilers that can detect some code bugs and errors, or writers who have their text editors like Word or something, which can show misspellings, business process model designers and business analysts should have their special tools for BPMN quality analysis. And such tools should take into account previous experience in process modeling errors detection. So therefore, we propose an intelligent system for quality evaluation of BPMN diagrams, which aims to prevent costs and time losses, as well as other negative consequences by early detection of process modeling errors. So first of all, we propose to formally represent a BPMN model as a directed graph structure, which includes different subsets of elements like tasks or subprocess, events and gateways, and also gateways can be given as additional subsets of split and joins. And the mapping function, which defines gateway types, also must be included into formal description of BPMN model, and it also consists of the binary relation, which represents sequence flows of business process models. And such graph can be obtained after the processing of BPMN files, which are given simply as the XML files with the solid structure and respective tags, which can be easily extracted, and the approximate classification of these tags, which correspond to each BPMN element, are shown in the right side here. So then we propose to describe a business process model using the vector of metrics, let's name it X, and then when starting the processing of BPMN model file, we should detect the number of start events, which is X1, the number of correct start events, which is X2, then it will be the number of all end events, which is X3, and the number of only correct end events, which is X4 here. And then we continue to extract the number of all tasks, X5, the number of only correct tasks, X6, and the same rules are basically applied for intermediate events. So X7 will stand for the total number of intermediate events, and X8 stands for the number of only correct intermediate events. And finally, for the gateways, X9 represents the total number of all gateways. X10 represents the number of only correct gateways, which have more complex detection rule. It says that gateway must either split or join process into or from several branches. And the latest metric X11 represents the total number of inclusive gateways, which have the OR logic. And then using this vector X, we propose to define another binary vector R, the vector of errors representing invalid start events, end events, tasks and subprocess, intermediate events, and gateways. And one more vector of error weights should be introduced here as well. Initially, we can give it values equal weights like 0.2 if we have 5 elements here. And then such weights must be adjusted. And the general quality indicator signalizes errors in a business process model if this value Q goes below 1. So then, in order to solve the problem of error detection in business process model, we have designed the connectionist system as demonstrated here. This computational system structure is shown in the right side of the slide, and it takes all of these metrics we proposed as inputs and summarizes whether model has errors or it doesn't have. Let's discuss the details of this system, how it transforms incoming metrics into binary values for each of the quality aspect and then merges together. First of all, it uses indicator or characteristic function, and which definition is given here, as well as Heaviside or unit function, which is also given here to perform necessary calculation in the nodes, in the hidden nodes of this system. So using such flow, we can calculate and we can detect invalid and missing start events using respective inputs like start events and correct start events numbers. Then using such computational flows, we can detect invalid and missing end events as well as we can detect invalid tasks and invalid intermediate events of the business process model using the proposed computational flows, also described by the given equations. And finally, we can detect also with the proposed flow, we can make calculations to detect invalid gateways and ambiguous or inclusive gateways. They are not actually recommended for process modeling because OR logic makes it harder to understand where the process goes next, if simply describing this. So when processing BPMN models, the error weights are proposed to be recalculated, taking into account the relevance of the errors. We propose the idea, so the more often process modeling errors occur in business process models, the more urgent it's to identify and eliminate them. So we have proposed this algorithm, so our system can, let's say, learn from the interaction with the environment after it processes some sequence of BPMN models. As for the computational workflow, the experimental results we performed using the large collection of BPMN models we took from open GitHub repository of the Camunda company, and the software is written in as the Python script, which uses different packages to read and parse BPMN files and to store calculation results for subsequent analysis. And then, as for the result of experiments, we have processed 3,729 BPMN files that contain in total 6,137 business process descriptions. And using the proposed error detection techniques, over than 6,800 errors were detected in the processed BPMN models. Numbers of the models with detected errors are given here. And as for the changes, this figure demonstrates how error weights were adjusted after processing each of more than 6,000 business process descriptions, and the final weights we obtained for different error types are given here. So these obtained error weights reflect the idea. The more frequently considered errors occur in business process models, the greater an overall negative impact they should have on the total quality of BPMN models. Also, for example, we can demonstrate one of the analyzed BPMN models that describes an insurance recourse business process. It's taken from the collection of models we have processed, and according to the obtained results, it appears this model contains all the considered business process modeling errors, like the start events, which are detached from the workflow, tasks that start the workflow instead of events, tasks which split the workflow into several scenarios instead of gateways, and other errors which are demonstrated here on the slide and marked on the diagram. As for the analysis of the obtained results, we have calculated quality values with initially equal error weights, dynamically changing error weights during the processing, and the finally obtained error weights. So the demonstrated table and box plot here show that in the set of real business process models created by different people 25% are of poor quality, 50% are of moderate quality, and remaining 25% are of high quality. Also, the distribution of differences between quality values before and after error weights were adjusted shows significant changes in quality estimations for 25% of business process models, and moderate changes for 50% of models, and no changes for the remaining 25% of models. So perhaps there were those models which demonstrate the so-called perfect quality. Finally, we can conclude. Some of the conclusions are shown on the slide, but I would like to make some interesting observations. The most frequent process modeling errors are connected to the poor structure of end events and tasks. Less frequent process modeling errors are caused by the poor structure of gateways or using ambiguous OR gateways. And the start events or intermediate events are less error prone, but still impact negatively the business process model quality. Also, we can conclude that proposed approach allows the system to learn over time. For example, some errors may not occur for a while, but still have significant weights and could hide the more relevant errors that occur frequently. And the statistical analysis allowed us to define thresholds we can use further to classification of analyzed BPMN models if they have low quality, moderate, or high quality. So in the future, using our system, we would like to consider the development of a software tool, and because it may process large collection of BPMN models, it could also employ big data or business intelligence capabilities for efficient data processing, visualization, and reporting. Thank you very much for your attention, and I'll be glad to answer the questions.
Thank you, dear Andrei. Questions, please, dear colleagues?
I have a question. May?
Yes, yes.
Yes. Thank you for your report. Very interesting. I have a question about your initial date. You said about quality analysis, but quantity initial date. What methods for obtained quantity date? And second question about machine learning. Examples for learning, for teaching machine learning's network, neural network. Yeah. Firstly, about quantity estimation methods.
Okay, so first of all, to get, for example, this model is also a BPMN model, and now it's like a picture, yes? But all BPMN models are represented as XML documents, in machine readable format. So we can, as a graph, basically as a graph. So by processing this graph, but in this graph, all the vertices have different types, and by processing this graph vertices, counting the vertices of different types, and analyzing basically the degrees of these vertices. For example, task must have one incoming and one outgoing flow.
Yes, it's understood using logic approach. Logic.
Yeah. To get initial quantitative inputs, which then are put into. It's a relatively simple weighted sum model, but it's reversed, yeah, because we need to calculate not the degree of errors, but the oppositely, the degree of conformance to modeling rules, not how it violates the rules. Yes, and then and the second part of the question was how to
teach of machine learning for machine learning algorithm, the firstly initial date.
Yeah, maybe I put here, I put this word learning in quotes because maybe it cannot be understood as learning in traditional way when we have like known inputs and need to train our model, known inputs and outputs, and need to train our model to feed.
I understood in future maybe because with
Yeah,
your
yeah.
big data. Yes, understood.
It's like early idea, but I'm glad it received some interest. So now we use the weights adjustment. So this learning is basically adjustment of weights that represent different types of errors. And as many models, as many experience this system have, as many models it process, it adjusts it weights to make the more frequent errors be more important because as we know, if these errors are frequent, then it means something. It means that such problems occur frequently in
Yes,
business
yes,
process
understood.
design. Thank you very much for the question.
Thank you.
Thank you. More questions, please? No more questions. Thank you, dear Andriy.
Thank you.
Our second plenary presentation is collaborative decision-making models in flight emergency landing geofiler on takeoff by Tatiana Shmaleva, Yulia Sikerda, Maxim Yetsko, Ilya Marenkov, and Elizaveta Sagun, the National Aviation University and Flight Academy of the National Aviation University, Ukraine. Tatiana is speaker, yes?
Yes, I hear. Thank you for invitation. You listen me. I hear
Yes.
my call open too. Yes, just moment. Just moment. No, our report. Our report in continuum of report from our about big data and collaborative decision making. Our report collaborative decision making models in flight emergency landing gear filer in takeoff. Prepare this report Tatiana Shmilova. I am from National Aviation University. Yulia Sikerda from Flight Academy of National Aviation University, Kropivnitsky. Maxim Yatsko, pilot and associated professor, National Aviation University. Ilya Marenkov, master degree from National Aviation University, and Elizaveta Sagun from Flight Academy, National Aviation University. Goal of the work. Moving my slide. Goal of the work. Building intelligence decision support system to improve the efficiency of collaborative actions in emergency situation for pilots, air traffic controller, flight dispatch, ground personnel too, and collaborative decision-making algorithm and models for operators in emergency. And many operators, pilot, air traffic controller, flight dispatch, ground service, and engineer, control of development of emergency and improving of effectiveness of decision-making in emergency, and examples. And main example about collaborative decision-making in emergency landing gear filer in takeoff. And questions on this slide you can see. Firstly, human factor problem, intelligence control model for intelligent decision support system for human operators in aviation, collaborative decision-making models, methods of collaborative decision-making models and examples, and main example from our article. And our team, research team, I am Sikirda Yulia, here too, Maxim Yatsko, Елизавета Sagun, and Ilya Marinko. This is the new participants in our team, master. And areas of our scientific interest, which is a human factor problem in aviation, decision-making models, artificial intelligence methods in aviation, professional effectiveness, and flight of manned and unmanned aircraft in integrated airspace. The first question about problem statement, human factor problem in aviation, because many participants and emergency and many wishes and many decision making and collaborative decision making models. This is an effective collective decision with minimal risk and maximum safety, and intelligence decision support system too. And on the slide you can see reasons of aviation accidents. And this is a conceptual model and evolution of conceptual model in aviation. From Shell model, I think you know about this model, Shell 1917. There are many models, Shell's team commander, team, and culture, Shell, socio-technical system, and artificial intelligence, modern conceptual model in aviation, and collaborative decision-making model, and integrated CNS system, connection, navigation, surveillance system in aviation. On this slide, technological, you can see chronological table of evolution human factor models. And our articles and book published about these areas with the decision-making models for pilot, for air traffic controller, for operator of drones, but now very interesting models, collaborative decision-making models in emergency. And about collaborative decision-making models and intelligence control model for decision support system. And the main problem, connection between air traffic controller and pilot of the aircraft, and steps of building artificial intelligence system. Now, firstly, expert opinions, expert system, next steps, decision-making and collaborative decision-making models for improve and prepare initial date in this system. Next steps, if we have big data, this is machine learning and deep learning, and now interesting intelligence system of decision-making combine nature and artificial intelligence, man-machine intelligence and decision-making. And examples in aviation of artificial intelligence system, connection between air traffic controller, integrated airspace, and flights of drone and manned aircraft in this airspace. And this is our new books published in USA about artificial intelligence application in aviation and airspace industries. And this is a neural network for obtained initial data. This is the opinion, expert opinion of air traffic controller and pilots. And using this neural network, we obtained initial data for intelligent decision support system. And about collaborative decision-making. What is it, collaborative decision-making? This is a problem in emergency decision-making, obtained optimal decision-making, because many participants, pilot, air traffic controller, flight dispatch, engineer, accept, and operator of drone now. And this is documents of ICAO, International Civil Aviation Organization, about this problem, and many documents about collaborative decision-making, a collaborative environment, conceptual model. And what is it? Collaborative decision-make models for us tasks, for us problems. This is integrated models. What, for example, certainty decision-making models, decision-making in risk, uncertainty decision-making models, and neural network models for obtained initial data in collaborative decision-making models. And pilots, air traffic controller, engineer, flight dispatch have different rules for decision-making in flight. This is stages of flight, aircraft, and methods. Methods for obtained optimal solution, methods for obtained effectiveness solution. The first methods, integrated models, certainty, risk, uncertainty. For example, we have certainty models. This is a decision-making in certainty deterministic models, but this is a complex process because many participants in this situation. For improving these models, we use decision-making in risk and decision-making in uncertainty and neural network 2 artificial intelligence model. And after this improving, we obtain decision-making in certainty, but this is an instruction for all participants in emergency situation. And second method, this is a collaborative decision-making models, individual and collaborative decision-making models in uncertainty, subjective, objective approach for obtained optimal solution. The first step, this is an individual decision-making for pilot, air traffic controller, for engineer. And second step, this is a collaborative decision-making models. And factors influence on decision-making on first step. This is a nature, this is a decision-making this is the influence of weather conditions, distance, technical characteristic of aircraft and runway. But second step, this is the opinion of participants from first step. And third methods we describing in our article on this conference. This is the methods of managing of development of situation. And the two methods, integration models and collaborative decision-making models, we present in these methods of control, of development of emergency situation. And examples, decision-making in emergency from aviation in air navigation system. The first example, bad weather conditions. Kyiv, Odessa, this is a road, aircraft Boeing 737, individual decision-making models for pilot, air traffic controller, and flight dispatch, and collective decision, optimal decision, collaborative decision-making model metrics about this task in this article. And second example about engine failure on aircraft in flight, Lviv, Kharkiv, and these participants too, the pilot, air traffic controller, flight dispatch, and how decision this problem, individual metrics and collaborative decision metrics, pilot, air traffic controller, flight dispatch, collaborative decisions. And next example about engine failure during takeoff, do a bad strike, engine failure. This is an interesting example. Antonov aircraft, Antonov N140H. And next, in continuum of this situation, where participants, artificial intelligence we obtained using expert opinion of pilot, air traffic controller, and engineer who took place in this situation. And example about integrated airspace and flight of manned and unmanned aircraft. This is a report will be tomorrow, our second report. And emergency. If we have aircraft, operator who control this aircraft must know about decision-making in emergency. And we have two examples, loss control and bad weather condition and decision for all participants in this situation. And example, flight from Uzhhorod to Khust. This is an urgent medical cargo and a difficult environment for delivering this cargo, and collaborative decision-making too. doctor, and operator of drone, and medicine specialist, logistic transportation company, and example for this situation. And about our main example, gear problem in takeoff. Gear problem in takeoff, this is a very difficult situation because many fuel on this aircraft. And analysis of this situation, factors influence of this situation, emergency situation, and problem. This is a individual work of our master degree, Ilya Marenkov, here. This is a decision making according to assist. This is the rules for air traffic controller and solution in this situation, decision making in risk and deterministic model. And our methods, this is a collaborative decision making models. And the main factors influence on this emergency situation. This is a distance, this is a technical characteristic of a runway and aircraft, and quantity of onboard, and type of aircraft, Boeing 737. And the decision of this situation, algorithm and decision from pilots, really pilots, Maxim, and decision-making, collaborative decision-making in this situation. This is a metrics, individual metrics from air traffic controller, pilot, and engineer, ground service, because this is a problem with gear. And decision to alternative airdrome, and metrics of collaborative decision making. And in future, we are planning artificial intelligence block for decision making in this situation. And what is next? Next, we are planning training of aviation specialists in collaborative decision making, because this is a problem for air traffic controller, for pilots, and in education, collaborative decision making in simulator, in practice, and in job too, if need. And you can see conclusions on this slide, and references on these articles. And report 2 will be tomorrow about unmanned aviation system and autonomous drones and flights of group of drones. And little information about our department. We prepare air traffic controller operators, operators on drone, and engineer who service of a navigation system. And our laboratory, many laboratory satellite system, avionics, unmanned aircraft systems, and our students, before, I think now too, have practice in Eurocontrol in education. And our trip, international trip in China, in Czechia, our students. And laboratory satellite system on our department, very interesting practice for our students. And training, decision making in navigation system. This is my course, decision making for master, for bachelor, for PhD students too. And on this slide, you can see this is the individual work of our students. After this work, we modeling decision making, collaborative decision making with pilots, air traffic controller who on job. And our published books in Ukraine about decision making, socio-technical system, and in Poland, in USA too, many books about collaborative decision making, conflict management, and now very actually about operator of drones and informational technology as main methods for decision making. Thank you for attention. questions? Did you have questions?
Thank you, dear Tatiana. Questions, please, dear colleagues? I have one small questions. What are the next steps and future directions for your research?
No, in the future, we are planning to build a really artificial intelligence model for decision making in emergency and many emergency situations, because with the problem in aviation, each emergency, this is the original emergency, and we have not big data for build neural network. In the future, maybe collaborative opinions of pilot, air traffic control engineer, and statistical data, and obtained added data, initial data for artificial intelligence system. This is a support of pilot in flight, for air traffic controller on board, or for operator of drones, because many informational artificial intelligence in future really is deploying.
Thank you. More questions? Again, please.
Why didn't you use a reinforcement learning?
Learning
Reinforcement.
learning this problem, because not initial data. Now we have only machine learning system, no, neural system building using machine learning. This is a statistical data, a little statistical data, and expert data from specialists. But maybe in future, edit data. This is a problem, big data obtained in machine learning too. No, maybe will be a new approach in science. No, but the main in decision making, this is the only operator, only human. Now we have hybrid combined system, artificial nature intelligence. But the main the main solution, only operator. No, for example, pilot in emergency. Only pilot. Artificial intelligence only support, technical support.
Then
Thank you. More questions, please? No more questions. Dear colleagues, now we will have time for a coffee break, but I propose to work without a coffee break. I propose to listen the following reports as long as there are no air alarms, no rocket attacks, as long as everything is fine with our connection, etc. Then we will be able to conclude our plenary session soon. Do you have any objections? No, thank you. Let's continue then. Now, our third plenary presentation is method for creating a computer agent based on the Jordan-Elman neural network for supply chains by Evgen Fedorov, Olga Nichiforenko, and Tatiana Neskorodeva, Cherkasy State Technological University, and Vasil Sud, Donetsk National University, Ukraine. Who is speaking? Evgen, yes, welcome, please. Evgen, please switch on your microphone.
method for creating a computer agent based on the Jordan-Elman neural network for supply chain. Motivation and state of the art. The fourth industrial revolution has brought about rapid changes in technologies, manufacturing, and social processes in the 21st century due to increasing interconnection and intelligent automation. Part of this phase of industrial change is the integration of artificial intelligence with robotics, with blurs the boundaries between the physical, digital, and biological worlds. In terms of logistics, fourth industrial revolution is expressed in high customer orientation, strong links between industries, dynamic supply chains. These characteristics can be achieved through the use of multi-agent systems. Currently, the main types of computer agents in multi-agent systems are reactive and proactive agents. In this work, we will limit our consideration to the reactive agents. Next. Traditionally, a simple reactive agent decides by applying production rules called behaviors, and this agent has a database which stores its current state and a production rule base. The condition of a production rule is a perception or a sequence of perceptions. The conclusion is an action. Advantages of simple reactive agents. Ease of implementation, quick reaction, quick decision making, robust decision making, in organization of multi-agent interaction. Disadvantages of simple reactive agents. Simple reactive agents do not use word models, so they must have enough information about their current state to determine an acceptable action. Since simple reactive agents will make decisions based on information about their current state, it is difficult for them to make a decision based on information about the current state of other agents. Weak learning ability of simple reactive agents. It is not clear how the resulting behavior of simple reactive agents emerges from their interactions between themselves and the environment, since inference is not used. It is difficult to build a simple reactive agent with a large number of production rules. Low level of intelligence providing low autonomy. Next line. Traditionally, a reactive agent with an internal state makes a decision through inference and has a database. It stores information about the state of the word in internal state, a word model, a knowledge base containing knowledge about how the word changes independently from the agent, and knowledge about how the agent's actions affect the word and the inference agent. Advantages of reactive agents with internal state. Simple logical semantics, high level of intelligence providing high autonomy. Disadvantages of reactive agents with internal state. The environment can change faster than an agent with an internal state makes the decision. The complexity of mapping the environment into symbolic logical perception is a form of logical formulas performed by the perception function. For example, there is a problem of converting an image or sound to a set of declarative statements representing that image or sound. The complexity of representing the dynamic environment properties of the real world using classical first order predictive logic. Representing even simple procedural knowledge in traditional logic can be quite difficult. The complexity of organizing multi-agent interaction. Thus, the lack of effectiveness of the computer agents is an irrelevant problem. Nowadays, instead of expert system with logical inference used in decision-making agents, artificial neural networks are actively used. Advantages of neural networks. The possibility of their training and adaptation, parallel information processing that increases computer power, the ability to identify patterns in the data, their generalization, extracting knowledge from data, so knowledge about the object is not required. Disadvantages of neural networks. A high probability of the training and adaptation method, hitting local extremum, and accessibility for human understanding of the knowledge accumulated by the networks, and they are distributed among all the of the elements of the neural network and are presented in the form of its weight coefficient. Difficulty in determining the structure of the network, since there are no algorithms for calculating the number of layers and neurons in each layer for specific application. Difficulty in forming a representative sample, thus known if the network satisfies all the criteria. To improve the efficiency of determining the parameter values of neural network models, meta-heuristic search is used instead of local search. Advantages of meta-heuristic methods: combines heuristic methods with an efficient strategy, low probability of the method hitting a local extremum due to the use of random search. Disadvantages of meta-heuristic methods: the method may not converge, the method is not very accurate, iteration number is not present when searching for a solution, there is only generalized method structure or method structure is focused on solving only a specific problem. Real potential solutions are inadmissible. The method is not designed for condition optimization. There is no formalized search strategy for parameter values. This raises the problem of constructing an effective meta-heuristic optimization method for training neural networks. Next, purpose and objectives of the research. Purpose of the researchers is to develop an agent based on an artificial neural network. Objectives of the research. Purpose, a formal description of reactive agents functioning models, propose a formal description of neural networks, base reactive agents functioning models, create a neural network model for the proposed agent with internal state and feedback, propose a performance assessment criteria of a neural network model for the proposed agent with an internal state and feedback, create methods for determining the parameters value of the neural model for the proposed agent with internal state and feedback, perform numerical studies. Main results. Formal description of the reactive agents functioning models. Simple reactive agent functioning model. Perception function maps the current state of the environment into perception. Action selection function maps a new perception into a new action or maps a sequence of perceptions. New and previous into a new action. Reactive agent with an internal state functioning model. Perception function maps the current state of the environment into a new perception. State change function maps a previous internal state and a new perception into a new internal state. Action selection function maps the new internal state into a new action. The functioning model of a reactive agent with feedback proposed by the process. Perception function maps the current state of the environment into a new perception. Action selection function maps a new perception and a previous action into a new action or maps a sequence of perceptions, new and previous, and a sequence of previous actions into a new action. The functioning model of a reactive agent with an internal state and feedback proposed by the authors. Perception function maps the current state of the environment into a new perception. State change function maps the previous internal state and new perception and previous action into a new internal state. Action selection function maps the new internal state into a new action. Formal description of the neural network based reactive agent functioning models. The four main functioning models of reactive agents based on shallow neural networks are possible. For a simple reactive agent, the nonlinear regressive autoregressive model corresponds to forward neural network, nonlinear autoregressive neural network. For a reactive agent with feedback, the nonlinear input-output model corresponds to the Jordan neural network, nonlinear autoregressive mover, average neural network, normal For a reactive agent with an internal state, the nonlinear state space model corresponds to an Elman neural network or a simple recurrent neural network. So, for a reactive agent with an internal state and feedback, the nonlinear state space model with backward output corresponds to the Jordan-Elman neural network proposed by the authors in this work. Jordan-Elman neural network model. The structure of the Jordan-Elman neural network model, the hidden layer output signal calculation, the output layer output signal calculation, performance assessment criterion of the Jordan-Elman neural network model. In this work, to determine the parameters values of the Jordan-Elman model, the model adequacy criterion was chosen, which means the choice of such values of parameters that deliver a minimum of the mean square error, the difference between the model output and the desired output. Determine the parameters values of the Jordan-Elman neural network model based on the Adam method. Initialization, number of training iteration, initialization using the uniform distribution of the interval weights, as a zero vector of the first moments of length is set, the zero vector of the second moments of length is set, setting parameters, setting the training set, the number of the current pair from the training set, the output signal initial calculation for the first layer, the output signal calculation for each layer, forward propagation, calculation of error energy, setting synaptic weights based on the generalized delta rule backward propagation. The vector of weights is formed. The vector of partial derivative gradient is formed. The vector of the first moments is calculated based on the exponential moving average. The vector of second moments is calculated based on the exponential moving average. The weight vector is calculated as the first and second moments are corrected due to the initialization by zero, and the training step is scaled. Checking the termination condition. Determines the parameters values of the Jordan-Elman neural network model based on the modified meta-heuristic methods for charge system search. Charge system search is based on rules from electrostatics and Newton's second law from mechanics. The position of each particle in space corresponds to a solution vector of parameters values. The target function is the adequacy criterion of the neural network model. In this work, a modification of this method is made. An LM simulation is introduced, which allows you to explore the entire search space as the initial iterations. The exploration parameter is small, the exploration parameter is large. And as the final iterations, the search becomes directed. The exploitation parameter is large, the exploration parameter is small, while the operation and research parameters change normally. Initialization, setting parameters, randomly generating the best position vector, creation of the initial population, order by target function, put best first particles into the memory, determine if one particle is moved towards another and is believes that all good particles can attract bad ones, but only some bad particles would determine the global bad position. The sphere radius calculation, the particle charge calculation, calculation as a gap between two charged particles, determining one particle is moving towards another, and it believed that all good particles can attract bad ones, but only some bad particles can attract good ones. Determining if the particle is inside sphere, calculate the resulting electrical force acting on particles inside or outside the sphere, taking into Ohm law, a calculated particle acceleration, modify the position of the particles, taking into account Newton's second law and simulation NLM. Modify the position of particles that are out of bounds. Modify particle speed, order by target function, modify memory, stop condition. Experiments result and discussion. The simulation of the determination process of the parameters values of the neural network model based on the modified methods of charge system search was carried out in the MATLAB package using the parallel computing tools. Setting parameters. As a function of decreasing the NLM temperature is determined by the formula and is shown in figure 1. The dependence in figure 1 of the NLM temperature on the iteration number shows that the NLM temperature decreases with an increase in the iteration number. The operating parameter is determined by the formula and is shown in figure. The dependence figure 2 of the operating parameter on the iteration number shows that the value of this parameter increases nonlinear with time. The research parameters is determined by formula and is shown figure 3. The dependence figure 3 of the research parameter on the iteration number shows that the value of this parameter decreases nonlinear over time. To determine the structure of the Jordan-Elman neural network model to determine the number of hidden neurons, several experiments were carried out, the results of which are shown in figure 4. The number of input neurons was 8, the criterion for choosing the structure of the neural network model was a minimum mean square prediction error. As can be seen from the graph in figure 4, with an increase in the number of hidden neurons, the error values decreases. For prediction, it is sufficient to use 8 neurons as a hidden layer, since with a further increase in the number of neurons in the hidden layer, the change in the error value is insignificant. Thus, the number of hidden neurons coincidence with the number of input neurons. Methods for determining the values of the parameters of the Jordan-Elman neural network model by the criterion of minimum mean square error of the focus and computational complexity were investigated in this group. Conclusions. The work examines the problem of increasing the efficiency of computer agents in supply chains. To solve the problem, the existing computer agents of multi-agent systems were investigated. These studies have shown that today the most effective is the use of computer agent functional model based on the connectionist approach. To expand the range of tasks followed by agents, the work proposes a reactive engine with feedback, which makes a decision based on perception or a sequence of perceptions and the previous action or a sequence of previous actions. Also proposed is a reactive agent with an internal state and feedback, which is an extension of the reactive agent with an internal state and makes a decision based on perception, previous internal state, and previous action. For a reactive agent with internal state and feedback, a Jordan-Elman artificial neural network was proposed, which is a combination of Jordan and Elman neural networks. In the course of a numerical study, the structure of its model was determined. In the course of a numerical study, the structure of its model was determined. The experiments performed showed that the number of hidden neurons is not less than the number of neurons in the input layer. The value of the mean square error does not change significantly, and the selected network gives results with a minimum error. Methods for determining the parameters values of the proposed Jordan-Elman neural network model were proposed. This made it possible to ensure high speed and accuracy of calculations based on the model. The proposed meta-heuristic method for determining parameter values allows the parallelization and uses NLP simulation, which allows the entire research space to be explored in the initial iteration, and in the final iterations, the search becomes difficult. The proposed method for determining the parameters values are intended for software implementation as a metal package using a parallel computing toolbox, which speeds up the process of determining the parameters values of the Jordan-Elman neural network. The developed neural network model and methods for determining its parameters make it possible to increase the efficiency of the agent's functional software that implements the proposed methods for creating an artificial neural networks based computer agent developed and studied with the database of the Ukraine logistic company. The experiments performed have confirmed the efficiency of the developed software and allow us to recommend it for practical use in solving supply chain management problems using multi-agent systems. The prospects for further research are to test the proposed methods on a wider set of test database. Thank you for your attention.
Thank you, dear Evgen. Dear colleagues, questions, please. I have a small question. What is the practical significance of your proposed solution?
For increased speed calculation, for example, parallelization process and increased probability recognition, for example.
Okay, thank you. More questions, please? No more questions. Thank you, dear Evgen. Our fourth plenary presentation is issues of formalization of risk management process in software design by Lyudmila Belousova, Lyudmila Grzezun, Natalia Zhikenova, and Valentina Fikalova, Academy of Cognitive and Natural Sciences, Simon Kuznets, Kharkiv National University of Economics, Skovroda, Kharkiv National Pedagogical University, and National Technical University, Kharkiv Polytechnic Institute, Ukraine. Who is speaking?
I am Lyudmila Grzezun. I am a speaker. Just a moment, I am sharing my presentation. Just a moment. Can you see my screen?
Yes.
Yes.
Okay. So, dear colleagues, I'm really happy to greet all the organizers and participants of the international workshop on intelligent information technology systems of information security. I'd like also to say thank you for the invitation to take part in the plenary session of our work. My name is Lyudmila Gryzun. I'm a professor of Simon Kuznets Kharkiv National University of Economics Information System Department. I'd like also to introduce my co-authors, Professor Lyudmila Belausova, Professor Natalia Zhitinyova, and Associate Professor Valentina Pikalova, who represent different universities of Kharkiv city, Ukraine. The topic of our presentation today is issues of formalization of risk management process in software design. Here you can see a short outline of our presentation. In terms of the urgency of the research, the risk management in software engineering is tightly connected with general management of the company and used to address threats at the different phases of software design. On the other hand, correct risk identification and tracking of the potential threats helps to enhance project success rate and feasibly obtain a quality software product. A well-founded and thought-over risk management plan allows also the team to evaluate the entire software project, build a strategy for its successful completion, meet deadlines, and so on. There are quite a lot of risk management models. One of the widely used nowadays is Carnegie Mellon Software Engineering Institute model of risk management, which includes and is based on the standard requirements and best practice recommendations for the risk prevention or disposal. However, in the studies, it is pointed out that there are a lot of challenges of these and other models' effective use in the domain of software project management, especially under the current Ukrainian business realities. Among these challenges, it's important to include that these models apply to standards developed by foreign organizations and intended for use in large IT companies. The risk identification also must be carried out by independent experts. And these models mostly contain recommendations that are not formalized, and they lack specific instructions based on the quantitative estimations can allow ambiguous interpretation. So as for these, for the responses, as for these to these challenges, therefore, it's national IT companies need a certain adaptation of the content of these documents to their production activities. The successful implementation of software project by domestic IT companies requires thorough scientific research on the improvement of risk management methods based on international acceptance and at the same time taking into account the peculiarities of crisis situation in the country. Also, the practice of modern software companies requires relatively simple and reliable instruments as for losses estimation and minimization, and calls needs for this more strict and formalized methods application. Thus, the topic of our research seems to be quite topical and relevant. And goal of our work is to build a formalized model for minimizing risk losses and to implement this model into the practice of software project design. As for analysis of the related papers made us to focus on rather approaches to building mathematical models for the risk management in software design, and there are a set of different research. The one group of research, understanding risk as a probability of a situation that can lead to a loss of expended profit or an event that can threaten the success of software project realization. This group of research detailed the typical stages of the software risk management, risks identification, analysis, planning, and monitoring, and built formalized model of the process of the risk management. For example, for the stage of the risk analysis, it was built formalized model for determining the total probability of occurrence of potential risk events. Also, in similar way, they were formalized risk management processes at all stages of risk analysis, planning, and monitoring. Another group of research presented a logical and algebraic modeling approach, which enables to obtain the model of risk impact estimation. And understanding risk estimation as a complex of measures to anticipate the possibility of getting additional income or some damage from the risk event arriving, followed by the measures to prevent the risk, the researchers present the model for a risk impact estimation as a function of assessment of the consequences of the risk event. This enabled to formalize the algorithm of risk estimation and to reveal the problems of the instability of risk factors and the needs for deep analysis of the initial information and risk factors as well. So the learning of recent studies on the problems of formalization of risk management in software design testifies that the high importance of the issues of cost saving and optimal resources distribution on purpose of losses reduction on condition of risk events occurs. And it's emphasized in the papers the importance of quantitative methods application to the stage of exactly risk analysis. Among the quantitative methods, special attention is focused on optimization method, which causes the importance of optimization models building, implementation, and investigation. And such attempts have been done in the set of papers. Also, the researchers prove the relevance of linear programming using for the building of risk assessment models and demonstrate the efficiency of this approach for the exact cases of risk estimation. For example, the case in software academic projects is presented and analyzed in some of the papers, where linear programming technique for risk estimation focuses on the project cost and workforce of the project, ensuring the budget do not exceed the computed cost index, and so on. The analyzed related papers gave us, on the one hand, the theoretical background of our work, and based on the approaches to the formalization of the risk management processes and the ways of such formalization in our work, it was formalized the task of minimization of potential risks losses in the software design as a quantitative method of risk analysis, which is provided after the risk identification. It was used the optimization method with the application of linear programming technique. The problem of minimization of risk losses in software design was formulated in our work as follows. Let us define the vector X, which consists of decision variables that are resources of a software project. Let us also define the PI as a probability of risk occurrence for the ICE resource, and the CI as a value of losses per unit of the ICE resource associated with the risk occurrence. Then total risk estimation R can be expressed as a product, which you can see on the screen, and we obtained in such a way vector R of the risk associated with the risks from X1 to Xn on project. Thus, mathematical model of the problem of risk losses minimization was formulated in such a way. It is necessary to determine the amount of each resource to be allocated for the project so that the objective function the function which represents the cost of compensation for the risks consequences is minimal. At the same time, a system of constraints of the availability of resources reserves and their ratio, which is formulated for each specific project based on its scale and features, as well as on the basis of the analysis of the identified risks, must be implemented. The system of constraints is formulated in the form of inequalities, which can be generally presented, for example, in such a formalized way. So in terms of the scope of the built general model, it can be used to solve exact problem tasks of risk losses minimization in the course of the software development. After that, in the built general and formalized model of the problem of risk losses minimization was implemented into the risk management practice of the exact project of an application development. As a case of such a project, this was taken TeamStream mobile platform for online and fitness classes, which provides coaches and trainees with necessary facilities. This said software project was developed according to the iterative model in which the development is conducted based on the initial requirements that are clearly defined, and then step by step they can be changed. So at the initial stage of the risk management, the risks were identified based on the SWOT analysis of the TeamStream project and understanding the risk as a probability of a situation that can lead to a loss of expected profit or an event that can threaten the success of the project realization. So they were revealed and identified threats of the project resources associated with the threats. Here you can see the results of this identification, and the threats were revealed from poor estimation of the project time limits to insufficient number of qualified developers, and they were associated with proper risks of the project. Okay. So at the next stage, the experts' evaluations of the probability of the risks event occurrence in the project and the costs of risk losses per unit of each resources were done, and the results of these estimations, you can see they were generalized and averaged. Then according to the Formula 1 presented above, there was obtained vector R. In such a way, the general model was implemented for the case of exact IT project. It is necessary to determine the amount of each resource to be allocated for the project, so that objective function, the cost compensation of the risk consequences, is minimal. At the same time, the system of constraints for all the resources has been fulfilled. And I'd like to say that it was built based on the analysis of the availability of resources of the project, the ratio and interconnections, the project weaknesses, the economic and physical meaning. The built model of the exact task was solved using simplex method. The results of solving reflect how the resources should be allocated on the project in order to minimize the cost of risks losses if the revealed threats come true. Thus, there was obtained the vector of resources, and with such resources allocations, the objective function f(x) takes its minimum value, exactly 5,790 conditional units. The analysis of the results showed that the obtained solution contains unambiguously interpreted quantitative estimates for the software project resources allocation aimed at minimizing the costs of potential risks losses. It also meets the project requirements in terms of resources availability and the mutual ratio, and doesn't contradict iterative model of software development which was applied for this exact project. The results obtained at this stage of the risk management were used in the subsequent stages of risk responses planning and monitoring. It allowed to elaborate specific strategy for risk responses and mitigation of potential risks associated with each of the project resources. In particular, based on the quantitative solution analysis, it was possible to decide whether to this exact threat and requires a response in general, or it just need to monitor it and step by step to mitigate it. So in terms of the prospect of our research, it would be beneficial to estimate the obtained by the author's general model sensitivity to all risk factors and to build the strategy to risk responses regarding the model sensitivity. In addition, it seems to be prospective to implement and investigate the built model at the software projects design according to different strategies of project development. So in conclusion, I'd like just to sum up our presentation. The paper is devoted to the important issues of risk management and software development and urgency of formalization of this process. In the progress of work, the problem of risk losses minimization of software design is formalized, and the general mathematical model of such a problem is built in terms of linear programming. The vector of decision variables is determined, the objective function at the cost of compensation for the risk consequences is built, the system of constraints is shaped, and in the terms of the scope, we can say that it can be used to different practical tasks. It was also probed and implemented in the practice of the risk management of real software project. The task was solved, which allowed to get relevant project resources allocations to minimize the cost of potential risks losses. The set quantitative estimations for the project resources allocation enable to elaborate specific strategy for risks responses and mitigations associated with each of the projects. Thank you for your attention, and we are ready to answer questions if we are.
Thank you, dear Ludmila. Questions, please, dear colleagues. I have one small question. You say that your approach, your model allowed to get relevant project resources allocation to minimize the costs of potential risk losses. What exactly do you mean by minimizing costs? Minimization of project budget costs, minimization of project time costs, or what?
Exactly not. Our function reveals or expresses the cost of consequences, of risks if they occur. That is the idea. And if we talk about the budget in general, it was used in to formulate and to shape our system of constraints. It was used for this one. However, the function itself expresses the value and the cost of potential losses. Yeah, value of costs of potential losses if the risk events occur and threats will come true. And our task was exactly to allocate resources in such a way that taking into account probabilities of the risks and the potential costs of each of the threats, how to minimize the whole cost of risk losses on the project.
Thank you. More questions, please, dear colleagues?
Thank you for the question.
No more questions. Thank you, dear Ludmila.
Thank you.
Our fifth plenary presentation is analysis of quality indicators of digital images obtained by different photo recording systems by Bogdan Kowalski, Мирослава Дубневич, Тетяна Голубник, Людмила Манік, Зоряна Сельменська, Ukrainian Academy of Printing, Ukraine. Who is speaker? Miroslava, yes?
Yes, it's me. I'm a speaker. I represented the authors collective from Ukrainian Academy of Printing from Lviv. Ladies and gentlemen, just a minute for my presentation. Okay, I think you see my presentation.
Yes.
Okay. Ladies and gentlemen, let me present to your attention our research analysis of quality indicators of digital image obtained by different photo recording systems. The modern digital photo equipment market is undergoing dynamic change due to inconstant trends among consumers of products in this segment. Since the release of the first CLR camera in the late 1990s, both the photographic equipment itself and the priorities of its users have undergone transformations. Until recently, there were two classes of digital cameras on the market: CLR with variable optics, so-called professional, and compact cameras with built-in optic. Today, the latter have practically disappeared from the market, and single lens reflex camera DSLR cameras have to compete with mirrorless system models and smartphone cameras, which are constantly improving. Computational photography in combination with LiDAR technology make it possible to form images not only on the basis of optical information, but also to calculate various characteristics of the photographed object for the subsequent improvement of data transmissions about it. The compactness of the devices, the efficiency in the dimensional of information, and the rapid development of digital technologies, which are actively integrated into the software of smartphone cameras, allow some analysis to predict the further narrowing of the market share of digital cameras. There is an assumption that by 2024, the quality indicators of photo image obtained by smartphone cameras will become higher than similar indicators of photo image obtained by digital CLR or system cameras. Modern technical and software tools in some models of advanced technical class smartphones allow for achieving high visual quality of digital photos. Some authors claim that the technical level of a smartphone camera allows for getting photos of no worse quality than those obtained by SLR cameras. This means that with small dimensions, mobility, and intuitively simple settings of the photography process, in contrast to the somewhat complicated process of shooting with an SLR camera, mobile phones with advanced cameras threaten to push SLR cameras out of the market. SLR cameras have a significant technical advantage. Matrix size from 24 by 36 millimeters, in individual models even more, and larger lenses with the possibility of optical zoom and selection of the aperture number. In contrast, smartphones are equipped with light-sensitive matrices of significantly smaller size. Average model with matrices 1 to 3 inch diagonally, and individual manufacturers adapt the design feature of smartphone cases to large dimensions of matrix, up 1 to 1.33 inch. The size of matrix determines the size of the elementary cell, the size of a single pixel. For small matrices in smartphone, this value range from 1.4 to 2.44 micrometers for flagship models, and 0.8 micrometers for mid-range models. When increasing the resolution of the matrix of light-sensitive elements to 64 megapixels and more, the pixel size does not exceed 0.8 microns in all smartphone models. In comparison, the pixel size of a full-frame CLR camera is 8.4 microns. This provides significantly lower noise generation, the greater output of photo reaction, a wider dynamic range, and higher light sensitivity of the matrix. Smartphone manufacturers are trying to solve this problem using pixel binning technology. The optics in the smartphone camera also differ from the optics in of SLR cameras, primarily in terms of design. This is mainly a combination of two or more cameras with different focal lengths and subsequent image processing by software named stacking. The smartphone camera software itself is combination with a powerful processor in the range of the so-called mobile photography, and it allows the use of computational photography technologies and in particular stackings. And due to the development of software capabilities and the mobility of the device itself, cameras in smartphones are conquering and practically absorbing the niche of image photography. Therefore, in many publications, SLR cameras are predicted to lose their position in the market quickly. However, the analyzed publications don't provide an objective analysis of the main quality indicators of digital photo obtained by a smartphone camera, but perform a subjective analysis based on the visual evaluation of the photo by the viewer. The goal of our research was the following: analyze the relationships between digital photo image quality indicators and technical parameters of photo equipment, determine the priority of individual indicators for the consumer of visual information. Comparative analysis of the quality indicators of photo image obtained by the photo registration system of the SLR camera and the smartphone. The working process of recording of optical signal by light-sensitive sensors of a matrix of semiconductor elements, the actual process of photo exposure occurs identically to photo recording system of different technical classes: a compact camera, a mirrorless camera, a system mirrorless camera, or a camera in a smartphone. In order to obtain a photo image of the subject, it's necessary that the light from source with a current distribution of radiation power over the wavelengths of the visible spectrum illuminated the object of shooting. The reflected light flux modulated in terms of power and spectral composition in accordance with the reflection coefficients of the surface of the object enter the optical system of the lens. The structure of lenses and prism of the camera's optical system of a camera with the distribution of transmission coefficient in the wave range of the visible spectrum forms an optical image in the plane of the matrix of light-sensitive elements. To ensure the registration of color-separate images, each elementary cell of matrix of light-sensitive elements is covered with three light filter, one of the color of additive synthesis, the so-called bioarray with transmission coefficient. Next. Thus, the integral response of light energy receivers, which forms the quality indicators of the photo image, is described the following function. Based on the obtained dependence, it can be concluded that the technical parameters of the photo recording system components greatly determine the quality indicators of digital photo images. The main indicators of the quality of a digital color tone image are tone reproduction, color balance, reproduction of memorable colors and gray balance, and soon reproduction of small details and clarity, sharpness of the image, structure characteristics, the presence of the defects in the image, for example, noise. Each indicators of the quality of a digital photographic image is established at the stage of exposure and depends on many factors: the hardware of camera, its software, as well as external factors, the power of spectral composition of the radiation at which the exposure is carried out, the reflective properties of the shooting object, and their dependence of wavelengths of light source radiation, which dynamically change during each exposure. In order to systematize all factors influencing the quality of a digital photo image, we build diagram of the causal relationship of influencing factor. The presented diagram demonstrates that the four main quality factors indicators are influenced by a number of factors. Some of them are the so-called external factors that either cannot be influenced or the influence is limited. There are the characteristics of the light flux as well as brightness and color characteristics of the shooting object. The listed factors on the diagram are marked separately. And we will exclude them from the further analysis of the priority of factors. We considered the procedure for realizing the quality of creating a digital photo image as some function, as argument of which will be the above factors here. In terms of terminology and essence, the identified factors are classified as linguistic variables, which is in the task of the process of creating a digital photo image can be parameter that affects the final quality. To do this, we build an initial graphic model, oriented graph, taking into account expert judgments regarding the pairwise influencing connection between the factors. The output graph will be used to rank the factors by the importance of influence on the research process, the result of which will be a multi-level model of quality factors of creating a digital photo image. For the synthesis of the linguistic model, we will use the tool of matrix theory and system analysis. To synthesize the model of process quality assurance factors, we will use the method which distinguished between their types by assigning different expert weight to each of them. The essence of the proposed method of ranking factors is that effective quality of the implementation of arbitrary technological process will be considered using the example of this analysis of relationships between factors related to the quality of a digital photo image. It's important to carry out further research on the basis of taking such definitions and statements into account. Finally, we got the following formula for calculations, where n is conditional number of the technological process factor. The graph is used to build modified diagrams of relationships between factors, create next table in which, in addition to the number of the factors, the directions of direct influence of each of the factors and the path of depends on other factors are given. We calculated the total weight value of the direct and indirect effects of factors and their integral dependence on their factors, taking into account the desegmentation and condition introduced above. In that way, we have got the partial sums of the factors weights, calculate the correction for negative value of the sums and form next table, which ensures the establishment of factors rank and their corresponding priority levels on influence on the process of creating a digital photo image. Using the data from the column rank factor, we built a multi-level model of the priority influence of factor on the quality of implementation of a digital photo image. As a result of the application of the ranking method, the rank of the factors were calculated on the basis of which a multi-level model of their priority influence on the quality of the realization of a digital photo image was synthesized, which can be used for further optimization of the weight value of the factors and the calculation of the alternative options for the implementation of the process of creating a digital photo image. Mathematical modeling indicated the priority of the material support of the photo recording system, in particular the light sensitive metrics and optics, and the weight of the inference of the software is lower. The obtained result of mathematical modeling make it possible to more accurately formulate the conditions of an experimental study of the quality characteristics of digital photographic image obtained by photo systems of different technical classes. As a test object for evaluating the listed quality indicators, a color image on a material medium was used, which consists of a chromatic scale and set of fields colored in the color of additive space, red, green, and blue, and the subtractive space, cyan, magenta, and yellow. Also, the test image includes objects of memorable colors, in particular human skin, oranges, and some others. The indicate test object was photographed with a SLR camera by Canon and smartphone iPhone by Apple in the mode of manual selection of the exposure pair with a light source balance in terms of spectral composition. The resulting digital photo image were digitized in parallel in JPEG, RAW, and DNG formats. The diagrams show color gamut of each image. Photos taken by a smartphone camera and digitized in DNG format and in JPEG format generated from DNG came closest to the color coverage of original. Instead, the images are digitized immediately into the format JPEG by software camera in smartphone, and format HEIG are characterized by a significant narrowing of the color gamut and exist of most colors, red, magenta, cyan, and blue, beyond the color gamut of the original. Therefore, it can be concluded that this happened as a result of additional image processing by smartphone camera software, which is configured to increase the saturation of color in the photo image. Regarding photos taken with an SLR camera and digitized in formats RAW and JPEG, their color gamut is narrowest, but not due to the distortion of color shades, but only due to reduced saturation. Because the shape of the color gamut figure of the specified photographs quite accurately corresponds to the color gamut figure of the original. It can be concluded that the formats JPEG and HEIG, the smartphone software creates a specific reproduction of color that don't correspond to the real ones. And the best color reproduction without additional processing was achieved when shooting with a smartphone and digitizing in the format DNG. Photos from an SLR camera also have realistic color reproduction and require minimal saturation correction during post-photographing processing. Thus, on the basis of the above, we can conclude that the smartphone camera, even in combination with advanced software, does not provide satisfactory color reproduction of the photo image. To evaluate color balance, we analyze the content of the main color of additive synthesis by achromatic shades. The graphical dependence presented demonstrate that photo digitized by smartphone software into format HEIG and JPEG are characterized by a significant imbalance in colors components in chromatic colors. Image in RAW format, DNG, has a higher degree of color balance, but some imbalance is still observed. A better balance of color components, especially in photo from an SLR camera digitized in RAW format. The covers of content of single color components almost completely saw inside. The same graphical dependencies allow us to evaluate the gradation transfer in the evaluated photo images. The most accurate tonal reproduction, close to the tonal reproduction of the original, is characteristic of a photo obtained by an SLR camera and digitized into RAW. Since the curves on the coordinate plane are as close as possible, to directly proportional tone reproduction. Another evaluated quality indicators, sharpness and digital noise level, are the so-called structural characteristics. For a consumer of visual information, these indicators are among the most critical, especially sharpness. Evaluate this indicator quantitatively by the width of the blurred zone at the border of the transition of a dark part on a light background or vice versa. The diagrams show that the higher sharpness is a characteristic of a photo image obtained by a smartphone camera and digitized in the Hague format. The level of digital noise, color and brightness component is displayed in the next diagrams. The lowest level of color noise is characteristic by a photo image obtained by a smartphone camera. The noise on image obtained by SLR camera most higher. So smartphone software is better and imitating the noise reproduction algorithms. The concluded studies proved that none of the studied photo recording systems can be considered perfect. Photos taken by a smartphone camera are characterized by a low noise level and high sharpness. This is an unequal advantages, and it can only be achieved by working with camera software. Instead, the color reproduction, tonal reproduction, and color balance of this half-tone image are unsatisfactory. Photographs obtained by an SLR camera are characterized by almost perfect color balance and good reproductions of individual single colors and memorable colors, for example, skin color. But the structural characteristics of the mentioned photo are somewhat outside the tolerance limits, but their level is not critical and it is subject to correction during post-photographic processing. So far, no advantages of any of the photo registration systems have been identified within the scope of this study. The obtained experimental results are consistent with the results of mathematical modeling, which indicated the priority of the material support of the photo recording system, in particular the light sensitive metrics and optics, and the weight of the inference of the software is lower. Therefore, it can be predicted that the competition of the systems will continue, and the improvement of the material base and software will open up new opportunities for consumers of these products. That's all. Thanks for attention.
Thank you, dear Miroslava. Questions, dear colleagues? I have one small question. What are the future directions for your research?
From other research, we think both of types of photo recording systems is concurrent on the market. One has one high quality characteristics, another has another high quality characteristics. Nobody's win. In this time, nobody wins. It's competition. Competition is continue.
Thank you. More questions, please? No more questions. And thank you, dear Miroslava. And our sixth and last plenary presentation is Intelligent Neural Networks Models for the Technological Separation Processes by Andrei Kupin, Dmytro Zubov, Yuri Osachuk, Rodion Ivchenko, and Vadim Sayapin, Kryvyi Rih National University, Ukraine, and the University of Central Asia, Kyrgyzstan. Who is speaker? Andrei, yes.
Dear colleague, do you hear me?
Yes.
Great. Just a moment, I will start my presentation. Can you see a presentation?
Yes.
I'm Andrei Kupin. I head of computer system and network departments of Kryvyi Rih National University. Your attention is invited to presentation of topic intelligence neural networks models technological separation process. Authors Andrei Kupin, Yuria Sachuk, Rodion Ivchenko, and Vadim Sayapin from Kryvyi Rih National University, Ukraine, Kryvyi Rih City, and Dmitro Zubov from University of Central Asia, Kyrgyzstan, Nared City. Next slide. Contents of our presentation. First is introduction. Second, formalization model-based networks. Third, research of the effectiveness of methods. And fourth is conclusion. Next. Kryvyi Rih region is known for the presence of numerous large industrial enterprise of metallurgical and mining industrials. First of all, these are 4 methane waste mining complex and 2 ArcelorMittal Kryvyi Rih plants. For more than 20 years, our team has been dealing with task of automation and intelligent control of technological process is such industrials. This is, of course, of outgoing problem today. As you know, this sector of economy before the war, Ukraine-Russia war, produced approximately 20% of Ukraine export income. The study introduction, the study of solving a problem, selection optimal, scientific for formalization of technological process in separation technology. Main aim is optimization control. A typical example is this process is beneficiation, or synonym, this term is separation of concentration of iron ore or magnetite quartzites. Numerous works of the authors, for example, Bodyansky, Bublikov, Markun, Trunov, has convincingly demonstrated that artificial intelligence technology holds the greatest potential here. This mainly process is such as non-linearity, non-stationarity, large number of parameters, incomplete information, etc. Despite of extensions of numerous scientific research in this area, some issues require ongoing clarification of adaptation to the specific this technological process. This implied the selection of architecture, for example, neural network topology, training methods, and hardware, software implementation, etc. Therefore, this paper examines several promising intellectual approaches and mathematical models based on use artificial network, neural networks. The next. This slide, we can see formalization models of the process based on neural networks. For example, the typical schema proposed for use in artificial intelligence. For example, neural networks, fuzzy logic, evolution, synergetics, to build the different scheme of automation technological process. As can see for this picture, each multifunctional technological process has several stages. The outputs of each current stage are the input of the next one. In this case, there may be recycle different time discretes, incomplete information on fuzzy information, etc. For example, such a typical technological process in the multi-stage as beneficiation or concentration and separation of iron ore or magnetite quartzites. The essence of this technological process is gradual separation of the useful component, iron, for example, from the waste or tails. In total, it's 4 or 5 such stages are usually used. All this speaks in favor of use of intelligence kybernetics approaches to solve such problems. Next. To begin the analysis, we consider a scenario where the many characteristic feedback on all technological parameters are assumed to have influence on process output. The process model is represented graph on next slides, and with the parameters of as nodes of the arts indicators that influence this process. This represents representation of technology process as a similar neural network, where the nodes contain its function. This converts same signals. It is known to that formalize the beneficiation technological process under the condition, this condition and the technological line. We need to consider a number of parameters as represent as a black box in classical cybernetics. Next slide will be show this schema. The result vector consists as parameters, information parameters and control actions, vector U, and other output signal, vector X and others, and where vectors V is vector input distribution, dispersion parameters input priori information, vector U is a control vector, and vector Y is vector is output parameters of the systems. This slide we can see just shown 3 black boxes, which are 3 stages of technological process. It shows that input and output parameters, control action, contribution parameter, recycles, and etc. From such statements of the problem, it is clear that such a process for foil is an essentially non-linear and non-stationary object. Therefore, the use of intelligent technologies is quite reasonable. In particular, today we have sufficient experience in study and implementation of neural networks to solve the problems on construction, design, mathematical models of technological process, for example, approximation, identification, neural control, optimization, parameters, and etc. On the next slide, we will detailed breakdown of the technological parameters for this schema. Where E is the number of individual variety, N is a quantity of stage varieties. Alpha, vector alpha is estimated array of grade. Xi is special every variety iron ore. Rho, vector rho is a index of characteristics characterized of physical properties of ore. G is vector is index this characteristics mineralogical property, and D0 is average of correlates before beneficiation. Q0 is area coverage or first stage of beneficiation, and M is count of stage of beneficiation process, quantity of stage. Q vector is processing out of each stage circulation. D is vector's average product occurrences. Vector PM is calculated is content in pool. BM is consumptions of the process, the meal, classifier and separation. Rho K is a pulp of density of the or is density separation. Beta P is estimated grade of products, and beta O is loss in tails. Beta K is quality of the concentrate, is output product, and gamma is vector gamma is an output industrial products. Gamma K is output result products as concentrate, and sigma is extraction of product, and sigma A is extraction of concentrate. Neural networks is successfully used for the synthesis of this system and dynamic objects. And neural networks have a number of processes, make them promising as analytical tools on control system in the task under this consideration. These are first of all the ability to many examples, the presence of large volume of monitoring data, interval of measurement of input-output system, and make it possible to provide the neural networks with represent many samples. Other important properties is ability of the neural network for adaptation or change of the properties of the control object and environment, as well as high resistance to failures to individual network due to the parallelism originally incorporated into this process. The ability of neural networks to predict directly follows from the stage generally of harmless hidden dependence between input and output data. Once training, the network is ability to predict future output values based on few previous value or current monitoring data with a high degree of precision. The research of the effectiveness of methods to evaluate efficiency of radial Bayesian networks and multi-line perceptron consider the problem as a function. We can see this slide for mathematical model and graphical object. The main idea of our approach in this study is the use the certain difference mathematical models. This will be quite enough to prove the effectiveness of the proposed neurostructure. Of course, we could show similar result of our research on real process data, but that is beyond the scope of this report. We can recommend to get acquainted with our works of the authors. Some of these publications are included in our reference. This is simple nonlinear ideal model that will be used to our research. The process of building a neural network model can be divided on several stages. First stage is data collection for analysis, formalization of the table of dependent on independent variables. Next stage is data processing and then preparation. There is a formalization of training and test samples, determine and range of parameters change, data normalization, etc. Next stage, choosing of the type of architecture and neural networks. The choosing type of neural network suitable of solving the problem. And next, building and training network in last one, model validation. Checking the model on the test set, estimation and model error, interpretation of result. For our model, we will be used for neural simulations, the neural toolbox, neural network toolbox of the MATLAB NNT package for use for building and training and modeling the same neural networks. This slide shows the result of approximation of nonlinear function using neural network architecture of multi-line perceptron. the properties of these approximations is very similar to real process data for beneficiation technological process. In picture 6a, we can see a highly noisy data, and picture 6b based on low noisy data. The function is modeling of highly noisy data with standard deviation s square 1.906 as 22% for multi-layer perceptron, and S square neural or dispersion of neural network is 1.63 or 20%. The deviation of the neural network from noisy signal is S square 0.944 or 9%, and the function should be a consistent weak interference. S square is 0.1845 or 2% is approximated multi-layer perceptron. And last S square neural network is 0.179 or 2%, and the deviation of neural network from noisy signal is S square equal 0.11 or 1%. And next experiment, we can see a function of approximated radial biased networks equal based on noisy data and based on low noisy data. The slide shows the result of approximation on nonlinear function using neural network bias on the user architecture of network of radial basic function. The properties of this approximation is very similar to real technological process, and real data is picture 7a contains noise S square is equal 1.88 or 23% and approximated by radial basic network. S square for neural network is 1.68 or 20% deviation of neural network from a noisy signal is S square equal 0.85 or 10%, and at the picture 7b contain noisy signal, low noisy, S square equal 1.185 or 2% and approximated radial based networks. S square of neural networks is 0.184 or 2% deviation of neural networks from a noisy signal. S square is 0.185 or 2%. Next. This slide summarizes the data of previous experiments using neural networks, the structure base of multi-layer perceptron and radio-based network. Here the difference in accuracy of modeling of data with different level of noisy and clearly visible. And we can see both type of neural networks considered were able to build a regression model of noisy signal. Is all case the network demonstrate its ability to filter noise very quality. Although the radial based function networks showed a slightly larger deviation error in all cases, the difference from multi-layer perceptron is small and insignificant. Next slide. We can see result of training, one of scheme, which we research. This slide shows graphically, numerically the learning process of the neural structure that we used in the research process. Here, the goal was to explore the possibility of using various activation functions, and full text of our report contains more similar results. As we can see, very quality of this process presents. And conclusion regarding the neural networks architecture for approximation and the analysis for multi-layer perceptron and radial basic networks, we are both while each type has advantages and disadvantages independent task, both effectively approximate complex function by learning data. For example, multi-line perceptron has shown good results in experiments, cell data, including multidimensional data, making each model pattern hidden with them. In terms of training perceptron based on linear activation function for output, hidden lines with hyperbolic activation function showed the both term of coverage of the learning process and predictively. Therefore, the aim of the study has been fully achieved. Future results will be focused on identifying optimal methods for training this neural structure in real time. This will be include classical gradient algorithm based on neural, for example, backpropagation first on second order and other, and non-interactive approaches. We also plan to consider alternative neural networks architecture such recurrent and dynamic on deep, maybe deep learning structure. Thanks for your attention. We will be able to answer your question.
Thank you, dear Andrei. Questions, please, dear colleagues. I have one small question about what are advantages and disadvantages of your approach compared to the known approaches.
Disadvantages. I think that is a problem for maybe training methods we will present on the research for this structure is for in case of data is data of technological process real in real time is very noisy and maybe in this case maybe present any fuzzy information of information that not not measuring in real time or hardware that we measure to detect this parameter is absent. In this case, we need to predict this situation, to predict these parameters, and in this case, maybe non-correct data will be a problem for use in this schema of automation system. I think maybe and other disadvantages of this approach, but in modern time we will find other approaches to solve this problem. These methods, intellectual methods and neural networks, or hybrid method.
Thank you.
Thank you.
More questions, please? No more questions. Thank you, dear Andrei. Now our plenary session is over. Tomorrow we will start at 9 a.m. from section first, Intelligent Information Technologies. Section second will start tomorrow at 11:30 a.m. and the section third will start tomorrow at 3:45 p.m. Awards and close ceremony will take place on Friday, March 24, from 3:45 p.m. We invite all guests and participants of the workshop to take part in the discussion at tomorrow's section session. Have a nice evening, everyone. Goodbye. See you tomorrow.
See you. Bye-bye.
Goodbye.
Bye.
Goodbye.
Goodbye.
Goodbye. Goodbye.